Hello, my dear friends. Welcome to our YouTube channel ABC Max. The first table, general Fourier series, y equal to f of x a naught by 2 plus summation n equal to 1 to infinity a n cos n pi x by l plus b n sin n pi x by l. So our aim is to get these three constants. There is a naught, an as well as bn. These three are called the Fourier coefficients or Euler constants. This whole term is called the constant term of the Fourier series. This an is called the coefficient of cosine term. This is called the bn is the coefficient of sine term. It's okay. That is my requirement. Any function can be expressed as in this format. But in this form, there are three unknowns a0, an and bn. So how to get those three unknowns? Let us see what are the corresponding formulae to evaluate these three constants a0, an, bn. I am going to start with the general Fourier series. So the intervals are 0, 2l and minus l, l. In generally, the interval is defined for c, c plus 2l. C is any constant. When I substitute c is equal to 0, I am getting 0, 0 plus 2l, it is 0, 2l. What is meant by range? Range means upper limit minus lower limit. That is the right hand side limit minus the left hand side limit, or the highest value minus the lowest value. The difference. So 2l minus 0 is 2l. When I substitute c is equal to minus l, because I told you c is a constant. Substitute c equal to minus l, I am getting here minus l, here minus l plus 2l. So I am getting that minus l, comma, what is minus l plus l? 2l plus l. So that's why I am getting minus l, comma, l. What is the range? The range is maximum minus minimum, or the right hand side value minus the left hand side value. So L minus of minus L is plus L. So L plus L is 2L. So anyhow, the range is 2L only. So that's why this is called the full range series. C is equal to 0 and C equal to minus L. If you substitute L equal to pi, I am getting the two interval 0, 2 pi and minus pi, pi. That is the second table. Let us see the first, this one. What are the corresponding formula, set of formula to get the a0, an, bn? What is a0? Is a constant term. So integrate the given function over the interval with respect to x and multiply by the half of the range. Please see that half of the range. So 1 by L. Integrate the function f of x over the given interval 0, 2l. What about the an formula? Can we do the same integration over the interval 2l, 0 to 2l f of x? Sorry, it will give only the constant term. Already we used that formula. So this time can you look at the Fourier series? What is an? An is the coefficient of cosine term, cos n pi x by l. So let us include cos n pi x by l along with the f of x. Do the integration with respect to x and multiply by the 1 by half of the range. How to get the interval value? As you know, Bernoulli formula. So you applied Bernoulli formula to get the an value. Can you guess what is the bn formula? Yeah, 1 by l because half of the range. Integral 0 to 2l is correct. F of x. Can you see that? What is bn? Bn is the coefficient of, yeah, you are correct. Yeah, bn is the coefficient of sin n pi x by l. So it is f of x into sin n pi x by l dx. That's it, over. So once I repeat that, a0 is integrated with respect to x of f of x alone. Multiply by the 1 by the half of the range. The range is 2l. So 2l by 2 is, that is 1 by 2, 1 by l. An is the coefficient of cosine term. So we include the cosine term to get the an. For bn, to include the sin n pi x by l. To get these two values, better the safer side to apply the Bernoulli formula. Can you guess what is the formula under the interval minus L comma L? The same idea once again, because for the minus L comma L, anyhow the range is 2L only. So the A0 formula is 1 by half of the range and integral minus L2 plus L f of x dx. Because the interval is now different, minus L comma L. What about an? An is the same case, 1 by half of the range, integral minus L to plus L, f of x. Anyhow, the an is the coefficient of cos n pi x by L. So, we may include cos n pi x by L dx. And similarly, in the similar manner, we get the Bn formula, 1 by L, integral minus L to plus L, f of x sin n pi x by L into dx. Right, sir? So this is the way to identify, even you can easily guess the formula to find the Fourier coefficients A0, An, Bn with the help of the given range. So this is the table number 1. Now what about when I replace L is equal to pi? When I replace L equal to pi, what happened? This becomes cos nx. Why? Because when put L equal to pi, this pi and this pi get cancelled. So the terms becomes very simple. Cos nx sin nx. Similarly, in the case of L equal to pi, this becomes cos 0 to 2 pi. So 2 pi minus 2 pi, it is equal to 2 pi minus 0 is equal to 2 pi. So the range becomes 2 pi. In the same side here, by putting L equal to pi, we get minus pi comma pi is equal to pi minus of minus pi is equal to 2 pi. So the range becomes 2 pi only. Now can you change the entire formula? What we will get? The Fourier series now changed. A0 by 2 sigma n equal to 1 to infinity an cos nx plus bn sin nx. So the formula for A0 is 1 by pi integral 0 to 2 pi f of x dx. What about an? 1 by pi 0 to 2 pi f of x cos nx. Why? Because an is the coefficient of cos nx. So whatever we have along with the an term, that should be used for integration. Similarly for the bn, it is sin nx was there. So when I replace L by pi, I am getting 1 by pi integral 0 to 2 pi f of x sin nx dx. The same manner to get the minus pi comma pi interval by putting L equal to pi. So integral minus pi to plus pi f of x dx. This is the formula for the A0. And for the an, 1 by pi integral minus pi to plus pi f of x cos nx. So once again repeat that whatever we had along with the an, that term can be used to get the value. For the bn, sin nx was there, so I can use sin nx. So here also we changed in terms of pi. So once the interval is pi, you may see the formula is very simple. It is in terms of cos nx or sin nx. Once it is in L, that is the general Fourier series in terms of L. When you give the particular values to the L, you may get the particular case of the Fourier series, that is a pi format. So the pi format, the terms are very simpler than the general format. That's it. Thank you. Thank you so much.